A right triangle is a triangle that has one 90-degree angle. The sides of a right triangle that form the right angle are called legs of the triangle. The side opposite the right angle, or the longest side, is called the hypotenuse. The Pythagorean Theorem is used to find the length of a missing side of a right triangle. Notice in this figure we have a right triangle. That's typically indicated by this square in the corner. This is a 90-degree or right angle. The side opposite the right angle is the longest side, called the hypotenuse, and then the two smaller sides of that triangle are called legs. The Pythagorean theorem states the length of one leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared. Two alternate formulas that we can use for finding the sides of a right triangle are given here. The hypotenuse is the square root of one leg squared plus the other leg squared. Or if we're trying to find the legs, one of the legs is the square root of the hypotenuse squared minus the other leg squared. Let's use the Pythagorean theorem to find the length of the missing sides. In this first example, we're missing the hypotenuse, the longest side. Recall that the hypotenuse, I'm going to abbreviate here, is the square root of the legs squared. So leg squared plus leg squared. First we have 12 squared, and then we also have 16 squared. And we're taking the square root of that. 12 squared, that is 12 times 12, is 144. 16 squared, or 16 times 16, is 256. And now adding 144 and 256, we get 400. So the square root of 400, which is 20. So the length of this hypotenuse must be 20 feet. In part B, notice we're missing a leg. The formula to find a leg is the square root of the hypotenuse squared minus the other leg squared. So we have the square root of the hypotenuse, which is 12, squared, minus the other leg squared. So we have 10 squared for that one. First we have 12 squared, that's 12 times 12, which is 144, minus 10 squared. 10 times 10 is 100. 144 minus 100 is 44. We now have the square root of 44. We'll have to use the calculator to approximate this one. The square root of 44 is 6.633249, and we can stop there. We're asked to round to the nearest hundredth, so really we only needed 3 decimals. The nearest hundredth is here. Look to the right of that 3, and we see another 3, which means we need to round down. So this is roughly 6 and 63 hundredths centimeters. That's the leg that we're missing. In example 4, we want to draw each triangle described and then find the length of the missing side. Round to the nearest hundredth if necessary. We have one leg is 30 inches, the other leg is 15. Looks like we need to know the hypotenuse. So let's say this leg is 30 inches, then this leg is 15 inches. we need to know the hypotenuse. The formula for the hypotenuse is the square root of one leg squared plus the other leg squared. So we have the square root of 30 squared plus 15 squared. 30 squared, 30 times 30 is 900. 15 squared, or 15 times 15, is 225. Then we add those, and we get 1,125. We'll need to use the calculator here to approximate that. Square root of 1125. That is 33.541. We're asked to round to the nearest hundredth, so we need these 3 decimals. 4 is the rounding digit. Look to the right of that, and we see 1, which tells us to round down. So what we're looking for is 33 and 54 hundredths, and our units inches. In the next example, we have a hypotenuse of 9 centimeters and a leg of 8 centimeters. So let's say this one's 8, this one's 9. What is this side? If we're missing one of the legs, we use the formula the square root of the hypotenuse squared minus the other leg squared. That is the square root of 9 squared minus 8 squared. Nine times 9 is 81. 8 times 8 is 64. We now have the square root of 81 minus 64. 81 minus 64 is 17. And we'll need to use the calculator to approximate that. Square root of 17 is 4.123. We're rounding to the nearest hundredth. So we're looking at the 2 as the rounding digit. Looking to the right of that, we round down to get 4 and 12 hundredths, and this time centimeters. In example 5, we again want to draw a picture and solve, rounding to the nearest tenth as needed. Part A, Jane wants to replace a net on a basketball hoop that is 10 feet high. If she places the ladder 4 feet from the base of the hoop, how long must the ladder be to reach the hoop? So let's say the basketball hoop is here. The ladder is going to be 4 feet from the base. How long must the ladder be? If the basket is 10 feet high. So we have a right triangle, and we're looking for the length of the ladder, this piece here, which is the hypotenuse of that right triangle. Hypotenuse is the square root of one leg squared plus the other leg squared. So we have the first leg, which is 10 squared, plus the other leg, which is 4 squared. Square root of 100 plus 16. That is the square root of 116. We'll use the calculator now. Square root of 116 is 10.77. And we are rounding to the nearest tenth, so that's 1 decimal. Look to the right of that, we need to round up. So we get 10 and 8 tenths, and in this case we're dealing with the unit feet. In part B, a wheelchair ramp is constructed to rise 1 foot off the ground and extend 13 feet. How far along the ground will the wheelchair ramp reach? So here's the ramp. We need it to extend 13 feet, rise 1 foot off the ground, and we're asking how long around the ground will it be? So we're looking for a leg. The leg formula is the square root of the hypotenuse squared minus the other leg squared. So we have the square root of 13 squared minus 1 squared. 13 squared is 169. 1 squared is 1. So we have the square root of 168. Get 12.96. And if we're rounding to the nearest tenth, we're looking at the first decimal. Look to the right of that, tells us to round up. So this 9 becomes 10, which means the 12 becomes 13. So we have 13 feet roughly.